Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, we are going to speak about the Van Hoff factor. Van Hoff factor. You'll get a complete information about the Van Hoff factor and some of the questions of Van Hoff factor. So, in case of Van Hoff factor, firstly, I would like to show some of the questions that we are going to solve at the end of this class. This is a question which was asked in 2016 of NEET examination, and then some of the different types of questions that is based on Van Hoff factor. We are going to solve this question later on. First, let me share a trick box for you all children. Here comes the trick box. Here it is. In this trick box, if you observe, when it comes to the Van Hoff factor, there are two cases that you observe. Number one is dissociation. The number two is association. In case of dissociation, there is nothing but where the electrolyte dissociates. Whereas there are two types, one is a strong electrolyte, the other one is a weak electrolyte. When it comes to the strong electrolyte children, you can observe the dissociation is 100%. That is why you should know that I is always equal to N, the number of ions. Whereas here, in case of a weak electrolyte, if you observe children, the dissociation percent is only 10%. If you take 10%, you can just see here the I value will be always greater than 1. Always remember, for a weak electrolyte, I value will be just greater than 1. Now, if you observe this side for an association of an acetic acid, where you can observe the I value will be always greater than 1. When it is a non-electrolyte, the I value will be always equal to 1. This is a very important trick box which helps for you to solve many of the questions. What you have to do is you just try to memorize this trick box where a strong electrolyte is present, I is equal to N. If a weak electrolyte is present, then I is greater than 1. If an association example is present, then I is less than 1. If a non-electrolyte is present, for example glucose, then I is equal to 1. Hope you have understood this trick box. I'll just tell you what is this strong electrolyte, what is a weak electrolyte, what is association, and what is non-electrolyte, and then we will quickly solve the questions. Let me tell you about the first thing, that is about the strong electrolytes. Strong electrolytes. In case of a strong electrolytes, as I told you, it is going to be, I'll take an example of some acids. I'll take an example of HCl. I will take an example of H2SO4. These are the example of strong electrolytes in case of acids. If it dissociates children, it becomes H plus and Cl minus. Therefore, here the N value will be 2 because there are number of ions are 2. If you take the next one, in case of H2SO4, it is going to form 2 H plus ions and 1 SO4 minus 2 ions. So here the number of ions formed is 2 plus 1 number of ions, 2 H plus and 1 SO4, 2 minus ions. Therefore, N value is 3. If I take a strong base, like NaOH, so it dissociates completely to form Na plus and OH minus. So the number of ions formed here is 2. Therefore, N is equal to 2. I'll take some of the salts example of K2SO4. In K2SO4, if you observe 2 times of K plus and 1 time of SO4 2 minus, ions are formed. Totally 2 plus 1, 3. Therefore, N value is 3. I'll take the one more, the best example, that is Al2SO4 thrice, aluminium sulfate. In case of aluminium sulfate, you can observe there is 2 times of Al3 plus ions and 3 times of SO4 2 minus ions. So here 2 plus 3, totally 5 ions are formed. So here all these N values is nothing but directly they'll be equal to N. I is equal to 2, I is equal to 3, I is equal to 2, I is equal to 3, I is equal to 5. This is what happens in case of a electrolyte, that is a strong electrolyte, a complete dissociation you are going to see here. Let me take an example of a weak electrolyte. A weak electrolyte. In case of a weak electrolyte, let me consider an example of acetic acid. This acetic acid is ionized. Let us consider it as ionized for 10%. If it is ionized for 10%, I'll just take it as alpha is equal to 10 by 100 or alpha is equal to 0.1. So when I substitute that is I is equal to 1 plus n minus 1 into alpha, 1 plus 2 minus 1 into alpha is 0.1. You may be just thinking from where is this 2 is coming from. When this undergo dissociation of acetic acid, children, if it undergo dissociation, you can just observe here, I'll write here CH3COO minus 1 ion and one more H plus ion. Totally how many ions are here? 1 and 2. That is what N value I have taken as 2. Hope it is clear. Now we'll go further. That is 1 plus 2 minus 1. When you simplify this whole 0.1, you will get a value of 1.1. I is equal to 1.1. Therefore, whenever there is a weak electrolyte like an acetic acid, always remember the I value will be taken as a greater than 1. Hope you have understood this part. We go for one more example. That is in case of a association, that is formation of a dimer. So in case of a dimer, what is going to happen? I'll just show you that also. For an acetic acid, okay, let us consider about association now. Association. In case of association, if you take an example of an acetic acid which is going to be dimerized in benzene up to 10%, it is dimerized up to 10%. It is dimerized. It is dimerized. The meaning of dimerized is nothing but it is getting associated. So when it gets an associated, we'll just take it as that is alpha is equal to 10% by 100 and that is going to be 0.1. As I have mentioned in the trick box, the formula for association is going to be I is equal to 1 plus 1 by n into minus 1 into alpha. The alpha is how much? 0.1. Therefore, let's just take it as 1 plus 1 by n into 1 into 0.1. So here what is n value? N value is again it is 2 because it is acetic acid. It forms 2 ions. 1 by 2 minus 0.1. So when you simplify this, children, it is going to become 1 minus, if you subtract half with the minus, that is 1 plus 0.5 minus 0.5 into 0.1, or it is going to become 1 minus 0.05, or it is going to be what? That is going to be I is equal to 0.95. Therefore here I is less than 1. Remember, children, whenever it is an associate, the I will be always less than 1. And this is the formula which I just showed you in the trick box, in the previous trick box, where you can just see in this trick box. It's very easy. You need to memorize this. Strong electrolyte, a weak electrolyte, an association takes place. A dissociation, a strong electrolyte is present, I is equal to N. A weak electrolyte, I is greater than 1. Hope you have understood well in this. Let me quickly go for the questions now. I'll just show you the first, that is a best question, that is an easy question that was asked in NEET 2016. I am sure you all will solve this. Let me just show you how to solve this question. What is the question is? The Van't Hoff factor I for a dilute aqueous solution is strong electrolyte. Strong electrolyte, barium chloride is. See, they are mentioning that it is a strong electrolyte, children. It is a strong electrolyte. If there is a strong electrolyte, what happens? There is a complete dissociation takes place. Therefore, the example given is barium hydroxide. I'll take an example of barium hydroxide is what? Barium hydroxide. When this undergo a complete dissociation, Ba2 plus 2 times of OH minus, a total of 3, that is N is equal to 3. So if it is N is equal to 3, so what will be the I value? How will you find the I value? Can you find the I value? Yes, it is very simple. You know that directly you can write it as I is equal to N for a strong electrolyte. Yes or no? Yes, sir. Therefore, I is equal to what? I is equal to option 3. That is 3. Hope you have understood this question. We'll quickly go for one more question. I am sure you will solve this question very quickly. It's a very easy question. You can observe for association of I, is dash than 1. Is it less than 1 or more than 1? For dissociation, I is dash than 1. If you just look into this trick box, it is saying that if it is association, I is less than 1. If it is dissociation, I is, that is in case of weak electrolyte, it is greater than 1. Therefore, I'll just take this as the option A, where it is says for association it is less than 1. Yes, it is less. For dissociation it is more than 1. Hope you have understood this question, and let me just show you one more, a very important question where you can solve this, children. You can solve this. It's very simple. You can observe here. We have 3 aqueous solutions of NaCl which is labeled with A, B, C with a concentration of 0.1 molar, A is 0.1 molar, B is 0.01 molar, and C is 0.001 molar. So we order them. You just arrange the value of Van't Hoff factor for this. Remember, children, more the concentration. Remember, I am just telling you what is the concept. That is, one is 0.1, the other one is 0.01, the other one is 0.001. This is A, this is B, and this is C. So if you observe, more the concentration, this is the one which is going to be more the concentration, more will be dissolution. This is 0.1 is the one which has got more dissolution. More the dissolution, then more will be the I value. Therefore, I has got more the value. You can observe, if you write the greater the value, what will be your option? Can you tell what is your option? If you observe here, in these 3, the one which has got the lowest concentration is 0.001. Lower the concentration, more will be the greater. Greater is the dissolution. Greater the dissolution, greater will be the I value. So this comes first and then comes A. Therefore, option A is the correct answer. Remember, children, don't get confused in this question. I am just telling you, very simple. You just understand. This is the one which has got more dilution. More the dilution, more will be the I value, because its concentration is very less. It undergo dissociation very faster than compared to 0.1 molar. Hope you have understood everything, and that's all in this video. For more videos, subscribe to my channel. I will be uploading some more interesting videos that is related to your NEET examination, CET examination, as well as your JEE examination, children. See you again in my next video.